Right. Hopefully you can see some things here. Guess like something like that. Um, Let me know if you can't see this. If you have problems seeing the whole screen and so on. Let me just ping people. Oh, I already pinged people. I already um, wrote something here and there. Right. Uh, I'll just drop one extra message. Um, okay. Right. Right. Thank you. Okay. So today I was thinking of doing a demo. So this is going to be a quick demo, actually. I guess. Let's see if I'll do something after that. So recently, in the 0.7.1, we had operator overloading, right? So we can now create our structs, and then we can add function like this, for example. And all right, return self x plus other x. Right, and we say operator plus here. I don't think. Oh yeah, it's gonna protest the highlighting. Well, sadly, will be unhappy about that. But now, if I do something like this, we can then print what f plus b is. And let's see here. Okay, so so this should work. Famous last words, as usual. Right, so we get a 9 here, right? So as expected. So x is 9. So, but that's old news, right? Everyone has already seen this. I think, I don't know if I showed that you can also do this, right? You can also do you can overload this one differently. So you might want a more. Why did I do that? Okay. So then you can kind of do a self x plus equals other x, and then return yourself, for example, right? And to do show that this one is called, we can do a print, right? So this should be pure. This one doesn't need to be pure. So hang on, it should be, but I don't think it's implemented correctly. Right, so now we have f plus equals b, and we can print that one. Now we can print f afterwards here. You can do twice. Right, and we get this overload, hopefully. Right, oh, did I forget something? Right, okay, I called it the same. This. Okay. Wait, what happened here? I didn't. I have to pass myself by reference, otherwise it's going to be like it won't work very well. Oh, I didn't. Right, and then we have to do reference. So here we go. So it's 14, right? And that's expected. Okay, but that's not what I was going to show. So, but that was like a recap of the previous changes. No, so the next one is supplementing this enum. So we have enums, and we can have additional associated values. So, for example, int x in a string name, right? So we can have like ABC equals 1, and the name is ABC. Hello, ABC, hello, like something like that, and then we can have df, and it's 3, and we have df by, right? And then you can do something like foo equals ABC. That would be a inference of this one. So here's the ABC, and then we can just print. We can print. We can print the ordinal of this one, and we can print the x value of it, and we can print the name. So this is old stuff. This is like basic stuff from before. So you get these 0, 1, ABC yellow. Okay. But sometimes people want, you can't do. You can also do this, by the way. So you can print just if this, right? So then you get the ABC, right? The whole thing, right? So we have, if you see this part, you get all these, right? Okay, but the problem was people were doing things where they wanted to essentially have this number. That was what they wanted to convert things to. So they wanted kind of x equals f, right? So it's all like this. Not necessarily int, but you get the point. So this doesn't work. It will say it's not convertible to that, but so you can cast an enum to int. You can get the ordinal by using ordinal, yes. But what we can do here is to then use what's new in 0.7.0, which is inline, and inline traditionally in the other features would. Oh, sorry, I didn't turn on the camera. By the way, I forgot about that. I didn't mean to not show you, so show you myself. All right, so okay. Okay, back to the screen, right? So what we did was to allow this. If I have inline, they will pick the inline and convert to that thing implicitly. So in this case, we inline x. That means that this works, and we can print that one. Now we just print x here, and you will get the 1, right? We could also inline actually the name if we wanted to, but then of course we couldn't have string. We would have to string instead, right? So in this case, it inlines. It converts implicitly to ABC hello. But you might want to run this in reverse. So to do that, there is an enum value. Oh, I always forget the name of this. Enum from value, right? And then you take the enum, and then you take whatever it is, like the name, for example, and then you take like def by, for example. And what you get here is an optional foo. So let's call it that, and now it will work. So we can just print that one and then panic if we didn't find it. I think that was the name from value, right? And yeah, we got the def by here. Oh wait, that was not what we wanted, right? We wanted the foo itself, right? So, but that was interesting. Okay, yeah, because now it's kind of not showing it's actually converting itself here. But okay, so oh yeah, I think there's like a special thing with the strings, so we can do like this instead. In this case, there won't be any conversion, so we can do like this. Um, oh, okay, so I forgot to panic there, and now we should get our def right. But this is kind of hard to find, and maybe we can make it nicer. So the nicer way of doing this is this. So let's look up def by. It works. Okay, so let's say we wanted to look up, we can always get the lookup will go for the inline. So in this case, we have name is inline, right? But you can have, let's take the field X instead and look for, something with 1 instead. So lookup field is the other method here, like a type method, and we get the ABC, right? We can also do this like if we don't have inline, then of course this won't work, but this will still work. So you can still do, getting the name, for example, that we wanted. So ABC, hello, and we should get ABC now, right? So let's see if we can do that. And we get ABC. And if I change something here, you will, it will crash or panic rather. Here it's a crash because you get a not found. And actually, this implementation is very simple. It's actually using code from the, this looks horrible. Whoa, what happened here? Holy moly. Okay, now it looks normal again. I know what happened. But it's the same thing actually as in the enum from, the enum from value thing. Except this one it's not a function, so it's just going to go and actually do the comparisons. So good thing is that lookup will be fast if you have just a few of them. It will be very long if you have, do them over and over again and you have a lot of elements. But actually it's going to compile to reasonably fast code on O1. Actually, if you have constant values, it will just find it. But this is it. This means that if you want this feature, you have to include enum lookup from the runtime. So I will try to look for a way to kind of. There are some other things in the runtime that are like super easy to include, that should be in there even if the stdlib is missing. You're doing it without the standard library, but you could always copy this, right? You could always copy this into your whatever standard library you choose to have instead. It just has to be in this runtime file, standard core runtime, and actually this reflected param is actually, that one is generated, by the way, by the compiler if it doesn't exist. So this one is recommended to always have. Well, so that was it, what I wanted to show you. Now let's see if there are any questions. So let's see here. So there's an hashmap. No, there's no hashmap. It's a linear search. And then what will the optimizer do? Well, that depends on what the implementation is. So theoretically, this is what it looks like now, right? But basically, there is no reason why you couldn't have something else in here if you wanted to do something optimized. For example, one of these would be like first expecting at compile time, inspecting the values that you are searching for, and see if they are they like maybe they start at 1, right? So it's 1 to 2, 1 and 2, and then you can just do this, like switch this lookup for some other features. So that's because it's at compile time. What I could do is like if some macro evaluates to like is a simple lookup. Like, let's say we implement that lookup with that particular type and particular value, right? So if there's a chance for a simple lookup, if that is the case, then we instead we return enum simple lookup with the same arguments, right? So this would be completely fine to do later. I just haven't done this because it's just so better kind of wait to do these optimizations until they're needed. So I mean, just get it out and let people think, like try it out. But because it's a macro, it's super simple to optimize. So if you have a particular enum type that you want this to be like, want it to work differently, then you could even do like something like if if at compile time the type ID equals my enum type ID. In that case, we just do this other thing. So you can patch the if you want to, you could always try to patch the standard library. Let's see if there was something else, anything else that yeah, one more thing. One more thing. So one change, right? There is one change, a major change, as far as slices go. So before it was like this. So you had a slice. Maybe I have a slice, simple foo. Okay, it's 1, 2, 3. And then I have another foo, another one, which is a bar, and it's 3, 4, 5. And I want to copy one to the other. What I could do then would be like this before. So let me print those, by the way. So print and then that I'll just cast it to a string, so it's readable. So this is what you could do before. So you can take, like, you had a slice on this side, which you knew then was a slice. If you do a slice like this, you're slicing. It's just not changing anything about it. But you could have like char3, right? That would work too. So if you have a slice here, then this would be a slice assign. And if it's saw that the type here matched the type here, then you would do as if it was both were slicing like this. But now the requirement is that if you are you can only do this. Like this would be scalar to every element, right? So if I run this, then I will assign 1 to all of these elements in foo. So okay, hang on, printf, right? So okay, so here we oops, I did something. Yeah, okay, good catch, right? So because that would not work either. So this is why it's good. Okay, so now I am overwriting that one and or not. The legal memory access. Did I get something wrong? Let's do like this, right? Okay, let's see. Oh, that's interesting. Okay, let's see if I can. Oh yeah, sorry. Okay, we want to, actually modify that memory, and then it's going to be super unhappy when I take the read-only memory, which is that string, and then try to write something into that. And now it's more happy, right? Okay, and so I couldn't do this. I can't do this now, but I can do this. So now I'll be. Actually, it's like I keep tripping over this part with what I think I can overwrite the memory. Okay, now I got a copy, right? So that's so this is a copy, and this would be a scalar operation. So before you could do this, but it was very unclear what was happening. And you can actually do you could always do you could do A, B, C, right? So that would kind of work. And then you would have these two, and they would do different things. So if you want to do this, if you want to do this, you can, but you'd have to do it like that. So now I get the ABC. So we overwrite the memory. So that's the new thing with the with respect to the slices. Now the good thing about this is that now this works too. So if you have a struct foo, and we say we have an element x and a element y, so maybe a double y, and I have an array of foo, right? So foo, and I want to initialize that. So I can do this. Now I can do y is 1.3, so like this, and then we can print maybe f, right? Maybe at least f0, so like this. So boom, it's copied to every element in. So even if you have this one, it's also copied in the same way, right? But before this didn't work because it had to do this without inferring that the type was foo, so that didn't work. Okay, so that was that. Let's see if there's anything else. No, I think that's. Oh yeah, and we also get another thing that we do get is that we can now do if on locals. So if I do defaults, that used to be not. That would before that didn't work. So in this case, it will work. It will break things because f can't be found. But yeah, so that's certainly sorry. Later. So this certainly works. Okay, let's see if there are any questions. So feel free to ask any questions you might have of regards to these in the case of assigning the slice, so the question is, are they all the same, right? They are all copies, so they're not the same instance. So if I do this and set that one to 3.4, then one is like that and the others aren't. Let's see if this one was clever enough to actually print the whole array. I don't remember. No, it didn't. It wasn't clever enough. Sad. Okay, but we can just for each over it. E and F. We do a print on E. So these are the elements now. So you can see one was changed. So before everything, so we have different stages, right? We have this stage before that change, and then we have afterwards, right? So they are, first they are all 0, and then they all turn to this value, and then here one is changed. If I set this one to a pointers for some reason, so that there's like a foo of pointers, then all of these will be the same pointer. Right. Okay, so I think that's answered the question there, I think. So, any questions regarding enums? I think, although it's kind of roundabout, this is not, it's still not, going back to enums then, right? So we have our enum, and it's foo, and we have, hello, which is 3, and then we have to have, inline int val, for example. We can write this, it's 5, baz is 112, okay, for some reason, right? And now we can do things like given a number, given a particular number x, then we can get the foo by lookup, and we assume that this is the right one, right? So and now if we test here with different numbers, we can test with 112, we can test with we can do like this actually. Let's do like this. So we have like this, and so if catch f, and then mismatch, no foo on, right? So on x, right? And then return, and then we go here, and you got f. Okay. So now we have some code. It will catch. If there's an error, we'll catch that. If it's optional, we catch the optional, we'll just write that the number doesn't exist, and then we return. So here we have a regular foo here, and we can try. So we can try 112. We can test like 0, and we can test 42. And if we would run that, we will get our there's no member method lookup on foo. Hang on. What did I do? Foo. So okay. Wait. So we got I got baz, I got hello, and then I got those two mismatches. So this is nothing you can't do by yourself, but I think this might make it feel more luxurious, having that built in. What you say, like, do you think this is an advantage of not having to, I could as well just do this, right? So enum from value foo was val x. This does exactly the same thing, but there's this nudging, and having this lookup will possibly make people more happy, you know, with the inline and back. It's still a bit strange to, I mean, sometimes I'm thinking like maybe we should ditch the whole inline thing and just, um, create a new enum, which I have resisted for a long time because it will have to be a separate type, which is the C-like enum, where you have assigned values to it. That one semantically is much simpler in some ways. Um, you can't get associated values with it though. So you can't, if there was one, I'm just saying that, let's say it was like a classic C enum. Yeah, let's say there was one, right? So we have one. Then it would have to be something like this. It will look like this, right? And you would have no conversions because it would just cost to an int. You would have to cast it, but going back and forth as a distinct type, it's essentially a constant. You could get some, okay, you can maybe iterate over, the different possible enum values, but there is no safety in knowing that it's a bar. And you couldn't go back, right? You couldn't get an ordinal of this without actually doing the same thing that we're doing with the lookup now. So you don't get away from that lookup, like if you want to do anything more with that. So the problem is the scene would have to be a separate type, and I'm just, it doesn't feel. It feels like inline is giving it more power to do more things. A lookup is also making it like more convenient and powerful, whereas adding a new type would be more. It would be like I've tried it several times. It just didn't seem like a good idea. Maybe I didn't have the right approach, but yeah, I don't know. Okay, very sad designer issues with things. You kind of end up with hating all your features a little, but I think that's healthy too. I mean, there's no feature that I couldn't cut from the language if I had a better solution. Right. Okay. So anything else? Like we have 8 viewers here. No one interested in asking any questions. Or is this perfect? By the way, 0.7.81. I actually scheduled that for I was planning on actually doing that a few days ago, but then today there were maybe like 3 bugs reported, which was very nice because those were small regressions from changes I did recently. So that was, for example, in those slices, I had to fix some things. So I did fix all those today, but and also actually did the this lookup thing, which we'll go into 0.7.1, right? I'm not really comfortable in adding features at this point. I feel like people might get weirded out by the amount of new stuff at this point. It doesn't feel nice to kind of see things changing. So I don't know. I don't know what you people watching this are thinking, but just trying to get rid of the rough edges, basically. And I don't know, like the enums now are they're still not C enums, but you can use them as C enums at a cost. If you go the conversion doing the lookup, but that's obviously that's a function and you're doing some lookup, and hopefully the name kind of indicates that it's not optimal. So I don't know. The current design with enums having ordinals and stuff like that makes them really useful for some things, but I'm not sure. Maybe I should drop the associated values and all of that and all the names and so on. It's possible to do that. It's just I always felt the enums were very hard to use in C because of the need that you have to kind of make these lookups actually by hand instead. You had used X macros typically to get some, printing out your state that was in an enum. I've done that so many times, and I always have to go get around. You do it by hand and try to maintain it. It's a pain. So and that's what I want to try to get rid of. Really, that pain point. I have another project, and like the bugs I run into with printing the state is so funny, because you kind of add a state, and then if you have like a array of the names, so you get the state name from the index. You from the array you index into down with whatever the number is in the enum. And if you forget to update it, everything is offset by 1. And then you can like go, how can it be in this state? So I was like looking at the app and I was like, it isn't possible. Like these state transitions are so weird. Because it was printing, the actual the incorrect translation, and you didn't get the array index out of bounds problem because the last state is often very rare state, like everything is completed or something. So I never saw that one, so I didn't really get the error, right? Of so yeah. Okay. That was a short one. So if no one has any questions, I might quit here. I should use this opportunity though to kind of give a shout out to this showcase repo that we have. Like, do add, if you have a project, do add your project in for make a pull request there for us in C3 showcase. It can be anything. It's just like I noticed that a lot of people were like looking for, oh, where's the LSP? Where's I want looking for some JSON parser or whatever. I'm looking for this or that, and there aren't any it doesn't matter that it isn't complete. People could still have a look at it and see like, oh, that's what I need, or I need something else. It's a resource for people who are starting out, like, oh, how do people solve this in C3? I'm thinking of it in that way. So it doesn't really matter if it's old. And the second thing is that I've realized I need maintainers for parts of the standard library in order to, get things really done. So we have the maths library, where we have One part is basically the complex type and the matrix, matrix types and quaternions. Those have to be correct, and they have to be have nice overloading, and hopefully going to a very optimized solution. They need to be converted to column major, and so on for the matrices. And kind of look at that. Do we need more than 3-dimensional, 4-dimensional? Do we need 5-dimensional? Should we add some more? What else? What other operations should we add? Not just the graphics ones, but other things, right? And then there is the decimal types. I was thinking that maybe I would do those. Some of them, decimal types for first fixed point binary, which is, you have fractions of 2. So you have like half, 1/4, and so on, to have like those kind of fractions. So you don't get whole decimal fractions, but you can. I also want a decimal type, so you can easily do your write your own money type, stuff like that. And there are different number of decimals that you might want to have. It's not necessary that you might want 2. It's maybe you want. I mean, there are some currencies that still have 3, but they are very rarely used. But then we also have Bitcoin, which has like a huge amount of decimals. But anyway, to get something like that into the standard library with generics would be real nice. But I need a maintainer. I mean, I need maintainers for things so that people can go and have some ownership of that code and kind of develop it as it as when they have time, they can add to it, right? And someone can feel like, okay, there's this code. I maintain this C3 standard library code. I try to update it with the latest new stuff that is needed for this particular thing. If you look at there's also need for threading the atomics, actually those primitives like mutexes and so on. That's also needed, and that's a bit more difficult because of the it has to be platform independent, so you kind of have to do cross-platform there. Yeah, and then we have to kind of see. Then I am hopefully I can take the responsibility for actually making sure that everything is in the standard library that should be in the standard library, rather than actually trying to write everything. Because I often have like this time to do a first version of it, and then it's not really complete, and I kind of, let's push this and people can try it out, and then I don't go back to it, and then it's like it sucks. It's bad. So yeah, if you want to do that, let me know in the Discord or by email if you're interested in some part of a standard library. It can be a small part if you want to. Like I just maybe you just want those a part of the math library that you think is really fun to optimize. And we can also think about that, like having, you can have fast math library where where things are very optimized for maybe low accuracy but speed. Right. If that was it. So unless anyone has anything to add, I'm looking here in the chat, but unless anyone has anything to add, I'll close it down now. I'll give you a little time to think about that. If you have some questions for me. By the way, this here is the IntelliJ plugin, and now it's getting better. I don't know if this works. And that one didn't find that one. I guess not this one either. Oh, maybe it did. But it does look up things, so at least locally it works fine. And you can rename it to, I think. Oh, looking at that many files, that was not nice. But okay, I managed to rename it. Hopefully nothing else. Also go, here we got foo, and we can jump to the definition of foo. So that works at least. And we're getting as also a bit of, if I have something like this, hello test, and it takes a param, which is x, most bestest param. Okay, if this is the case, then we should be able to hover, and we get like some information about that one. Oh, I think though it lost the parameter. I don't know why. It worked. I know it worked before. So yeah. The demonstration gods are not with me. What happens if I just do like that? Does it work then? No. Let's testing it out. No. Oh wait, maybe I didn't update my. Maybe I forgot to update things. What version of the plugin do I have? Oh, okay. It's well, I can't update now. All right, but that's it. No, not in the call, right? Yeah, okay, you are seeing me. Yeah. Needs to rewrite. It works on the definition. Sorry, I got distracted here, but you're looking for maintenance of parts of the math lab. Yes. So actually, all the parts of the library. If you look at the standard library, there are maybe not core because that's pretty much done, right? But we do have, there's like this glaring omission of Unicode. It doesn't know anything about glyphs or anything. And then we have some hashes, but not all. These are just some random ones that were fun to implement. There is the IO library. So the IO thing is absolutely not complete, and the path is something I'm going to fix. It's bad, but there are other things that we can, there are some streams and buffers and so on, but it has to be audited. And maybe here are some things doing the basic make tier and so on. But here there are more things that are accessible from the OS that should be exposed. We have, there's some rudimentary socket handling, but this doesn't do, there's so much left to kind of do here to do async handling of this, and there are OS versions of this, or OS specific versions that you might want to look into. For the threads, these pools are totally not good. We have a buffer channel now, I think, right? But we and on buffer channel that was contributed actually by someone who didn't. I don't remember who. They didn't write their name. But there's also so there's the atomics here, but we want like futexes and so on as well, and these should be probably audited and looked at, and maybe see like are they all right. At least someone has to like kind of take responsibility for each of these, right? So make sure that they are up to scratch, and there's just too much of this for me to look at. There are some sorts, like you have some quick sort and some insertion sort and counting sort, but there should be more of them. Maybe like it, I would like people who are interested. Compression should at least have what's it called, inflate and so on, standard zip stuff. There are more collections, and of course the atomic collections that are missing. So there is a bunch of omissions already, and not just that. It could be that something is missing some obvious method, and while you can write them yourself, you can patch the library yourself. It would be real nice to have it there, right? If that explain things. Right. Okay. So is Fox Kiana here is typing and has been doing most of this work on the IntelliJ plugin. So I'm super happy about that. So because having a good experience in the IDE is like a lot of people who write compilers for some reason, they kind of hate IDEs. I'm not a hater of IDEs. I think they are great because they can make sure that you are doing things consistently, reduce number of errors, can help you with doing static analysis and so on. You can see your error before as soon as possible. It's not just a parser error. You can do add things to get semantic checking and so on. So I like IDs. And I think IntelliJ is the best one I've used. That's why I didn't really look into helping doing an LSP, because I think that's generally haven't been as good an experience for me when I tried it out. Okay, someone jumped in here. Could you show how you generate bytecode from AST in this programming language? I don't generate bytecode. It's you just I just semantic checked it and then lower it to LVM IR. Is that what you're asking about? Hirasawa 1. Let's see if there's a follow-up to that. So I there's no bytecode. Maybe you mean the IR? Yeah, LVM has a builder I can show. Anyone else might be interested in. So here's the cogen, LVM cogen. Then you take the ST. Let's see, we can look at an expression that we generate. Okay, so we have what? Here's an sign expression. Right, so somewhere at the top here, we are going to assign something, emit something, assign to a variable. In this particular case, where it's an optional, then we have some special handling for that. And then we have to do some special handling because we might be assigning to an optional, so that makes this a bit more complicated with having blocks that you jump back and forth to. Then you finally emit something and then store it. And the store then is just LVM store to wrapper functions to all of the LVM. But here we have like here's actually something that is the builder. So here's the LVM building and extend, but we can look at the storage here. So Here we're going to load value. Let's go into that one as well. So we kind of go very deeply into this. So here we go, an LVM build load. That's the basic thing of it. You pass in the builder and then you give it the LVM address and so on. I just build this part like from bottom up. Right. Any other question? What has been okay? So what has to be done with the C backend in order for it to be usable? It has to be implemented. The reason why, what I started to like, okay, so I set up the C backend, and it's essentially it's practically nothing. It's practically nothing because I wanted simpler. Wanted the AST to be simpler in order to make the lowering easier everywhere. So I'm thinking like we're going to have the tilde backend, the C backend, and we want to have the LVM backend. So I don't want to do too much in in each of these backends, and that means that I have to try to linearize and simplify, kind of create sub expressions, or rather expand it to something else, and then the actual code will be simpler. And one of the big things that makes things a bit big is actually the passing around the error values, because those are jumps. And those jumps are not obvious in the AST, in the expression, because they will bubble up. And this is looking at Clang's codegen, that's normal. But if I can create an IR that already expanded with optional jumps, then more analysis could be made. And because those jumps don't exist if they don't exist in the final version of the AST, then none of the backends need to worry about the optionals. And that's where I want to go. So I've been working myself backwards from trying to see if I can create some types that are resolved that look different from the unresolved. So currently I go through the AST and thread through it, and then I resolve everything recursively in it. And that will change the state of that particular node from resolving to resolved, from unresolved to resolving to resolved. So it's idempotent, so you can try to resolve or analyze the same expression a lot of times, because it won't nothing will happen, because once you have checked it, it won't get checked again. And what I can do while doing that is to transform it as well. So I could be transforming it as I go through it. And if I do that, then we are then the C backend will be simpler. The tilde backend, when that's done, will be simpler, and the LVM backend will also be simpler. So I'm kind of moving towards that. Okay, I hope that was an answer. Okay, is it difficult to make a simple interpreted language fast? My language currently interprets by walking the AST. Well, walking the AST is the slowest thing, right? Actually, C3 is also walking the AST, right? And it's just doing, but the thing is, it's doing is checking do type checking and doing some macro compile time coding. It's not very fast, but it doesn't need to be super fast because C3 doesn't have that much compile time execution anyway. It's not It's not intended to be like a um, highly compile time heavily compile time language, unlike Jai and Zig. So I guess Zig is in a worse position now because from what I understand, Jai is actually going the full route of creating a bytecode that is then fast to execute. So if you want your interpreted language to be, this language be fast, then you would create bytecode and then interpret that or run that. Sig is weird because it's like having two different IRs and it executes them. It's a very odd design. But when then they have a lot of it, so then that actually makes the compiler pretty slow compared to C3. So okay, I don't know if that. I had a really weird discussion on the SIG Discord actually today, where they argued that explicitness is more important than readability. It's a very weird statement to me, because readability is basically the ability to understand what the code is doing, right? So so you can make sure that it's doing the right thing. As assembler is very explicit, but it's hard to read because it's just so much code to do the same, like a simple thing. So you want to semantically decompress what you're doing, right? You want to have like a print hello world that you can see like, this is printing hello world. You don't want to see like how it's taking. It would be very explicit to have some loop to kind of put each character into some memory region and then making it render. That would be more explicit, but it would also be harder to understand what it's doing. Isn't readability the function of the reader and not the code? Not only. Like, absolutely no. Like, readability is a function of, how used are you to reading that particular type of code. Like, if someone does, it's if you are used to reading a lot of functional code with that type of chaining together things and mapping things, then that is, from what I hear people doing that a lot think that's very readable because they can kind of look at the code, they know what to expect, what kind of patterns to expect, and then you can kind of do those things because kind of you can identify the patterns and you know what a segment of code will do, what kind of transforms that will happen. And if you not use that code, it can look very, very complicated and very, very hard to read. That's one aspect of it. But then there's actually a more objective aspect of it. So if you have something and it requires a lot of code to write, you write a lot of code to achieve something, then if a reader now wants to know what it does, the reader is not interested in actually checking the code, how it's implemented, but what it does. And this is often something you do. If you read a lot of code, you're not interested in like, how does this to uppercase function work? You just want to know that it's a to uppercase function. Like, because you are reading code here, which is calling code down. So you want to read as little code as possible because the code you want to check is here. It's not this code here. You want to check this code here to identify a bug, for example. Right? So if you are forced to read a lot of code to understand what the code down here does, then that is interfering with your ability to kind of read and understand the code at a higher level. So if the one has the printing each character and explicitly doing so, and the other one is just print the string, then if I'm not interested in how the string is printed, just okay, that part of the code is printing a string, that's not where my bug is, right? It's somewhere else, because it's not, it already printed the string and then something happened after that, right? I can identify that. But if I have to, like, what does this code do? And if you read a lot of ASM, that's kind of, or you know how to read assembler, but you haven't read a lot of them, like you can get stuck. But like, what does this code do? Okay, and then you can try something like, oh, okay, so it's moving there. Oh, it's a call to. Oh, okay, it's just. It was just printing something. That was not what I was looking for. It happened much later, right? And that in that case, this explicitness is a super big obstacle to readability, obviously, right? So you want, in that sense, you kind of want something at an appropriate level of detail, right? So allergy to readability, because I read a lot of code. So to me, readability is very, very, very concrete. It's a very, very concrete thing. Like for me, it's like, is this readable or is it not? But it obviously it's subjective, but it's also very, very important. So there are things that can make readability worse, right? Just plain worse. And that's if you make a language where it's hard to make out what the text is, right? What things are. So like very visually, it's hard to read because things are kind of clumped together in a, like, basically the layout is bad. One way a layout can be bad is if everything is starting to move towards, if it starts to move towards the right border, right? If you keep on indenting things, if things are like going into, back here, then I can say like that is objectively bad. Because now to actually see what the code is, I have to go back and forth. And that doesn't make me, I can't really scroll anymore because now things are back and forth. If I have a small screen and you have to think about, like, people have different screens, they have different problems with your eyesight and so on. So this is objectively bad. Like, don't make people look further, in here. And then there are, rules that are, handed down. Don't make names that doesn't make sense. Like, I can a decal, right? It's a decal, right? It's a declaration. I could make D, but if I call my declaration this, then yes, and then I call something else, it's just going to be bad. Or if I call my declaration E, which has no, or X or something, then that's obviously bad, and the readability will go down. So readability is very much like the writer of the code has a super big impact on the readability. There is so much horribly bad C code, which is basically the author didn't bother about the readability. They didn't think about like okay, maybe I have to, you know, put things together that happens together. Like this is not perfect. I would add actually comments on everything that's unclear. Do that in passes later on, often. But just have a uniform way to kind of your code has to look, have consistency. A consistency is a very very important for readability. Like if someone just, I hate people who do this. Like they think that's, this is like, my code is going to be look different from everything else. Now everything looks different. Like everyone is doing different things. This is very very hard to read because you think the code, you kind of look at the code structure. It doesn't matter if it's, this is almond braces, right? But it could be KNR. It doesn't matter. KNR is fine. You just have to look the same so you can kind of see, something looks wrong, right? You can see that something, for some reason, doesn't really match with everything else. It could be some type, or you can kind of scan for what you can see the patterns in the code. And if you can't do that, if there are things that kind of make it harder to read things. And very long names is also very bad because they kind of move everything. You have to scan so much and you have to go to this right hand side. Things that kind of push things down so that everything is very very long. So the biggest problem with Alman is actually that it's taking one more line here, actually. That is a legitimate concern in the case you need to have something compact. Vertically spreading out too much that you can't really see enough is also bad. But the horizontal thing is the worst because then at least here you have like the scroll thing, but this is, you can't really go back and forth like this. It doesn't make sense. So readability, if you read a lot of code, you hate when you can't read the code easily, basically. And there are some things that really make the code bad. Inconsistency, chasing the right hand corner, that's indentation. You can do that in any language. Anyone is like, it's just an if statement, and you're like going into the one. I know I can't show you anything because I don't do that, but there are people were like, yeah, indentation with 300 characters in, and that's where the code is, and that's I can't stand that. Sorry. Okay, someone else. We can see. Let's see what you said. This is the downside of kind of Twitch here because I don't see your stream here. I should probably find out how to put that separately. I guess you can put it next to the screen. But anyway, okay. So is it okay? Let me see if what I get. So I can see what I mean. But I think okay. Makes sense. Okay. If nesting in your code isn't bad practice, it should be avoided if possible with early returns and so on. So a frequent context change is not good. I don't know what you mean by that. But anyway, I prefer early returns. So that's how I write it. If you can do single return, I know that people swear by the single return for various reasons, but they have not just the kind of, some people would say, okay, you have to have one exit point. That's the rule, and that's the blah blah blah. This is how you should code, and that's just stupid. But if you have some style, that is readable, and you have a single exit and that works for you, then yeah, power to you. Um, there are ways to make that work, but the advice that you should do in one style, that you should do a single exit point, as in that's just the way to correct code. That's crazy. So likewise, maybe it doesn't make sense to have guard statements in some cases. I don't want to like give some stupid hard rules about what's the correct way to do things in that regard. So the nesting, yes, it tend to be bad practice. Sometimes actually you are forced to do that. If you're doing something like if you're having to, for example, write something right now in Objective-C, and you have to use libraries that are intended for Swift and Swift async, then you end up with having these horrible callbacks everywhere, and the callbacks get nested. They don't get nested with async in Swift, but they get super nested in Objective-C, and there's no way around that. You can, yeah, I mean, it looks horrible, but you can't really do anything other than maybe adding a function call instead inside of whatever callback you have. Why in some part it has nested if it wasn't possible to it has if it wasn't possible to return, would that make more difficult to read and thing? Why in some parts of your code it has nested if? Yeah, let's see. The question was like, why did you use nested if in some cases? Let's see if I have some example of nested if. Right. So okay, here we go. Right. So we're going to store. In this case, actually, we don't have nest. I mean, the normal thing would be to have an else if. I don't use that. I return. And then I return. Okay, I don't nest. I mean, the if has to be there because there are two if statements inside, and they all handle the same thing. Let's see if I have something else. Here is actually an if. Right, so if there's an optional expression, in that case we will need to do things, and there are two options. There is no way to do a guard statement here. Then you have to do it. I mean, it happens. I mean, you could put it off to another function, but the function call, but that's too much. So yes, it happens, but you try to avoid it. Basically that. Like I think I nest two levels or something. That's the normal maximum. Right, here's 2 levels. And the reason why this is so long is that this is if I do an early exit, then this is the uncommon case, right? So this is the uncommon case because it has a wrapping test, which is not normal. Yeah. Okay, let's see if there are any other questions. Really, sometimes it's difficult to. It's too difficult to turn a nested if code into plain if, and might not even be worth a try. I mean, I don't use nested. I don't like nested ifs. So if I have them, that's because that was the only way to do it with that. So for example, like let's see. I like to use switch cases, which are kind of ifs, but I find them easier. So this one could be turned into a switch case, and that might do that. So for example, in this case, we can write this as a switch instead, which I think is kind of clear, because you have more of a let's do if this if it's X, do this, if it's other, do that. And I think that just makes it a little easier to read. Now the downside of C is that you can't really you don't have the scopes, so you kind of end up having so you have to add these, which makes it much less nice to read. So you can get like this, right? So this is an alternative to the if statements, right? And then we have to do the default, which is like this default, and then break, and then everything is not indented correctly. But yeah, I mean, it's possible to do this instead. I've actually preferred this in most cases. But I mean, that doesn't address the if cases really. So it's just here we have some other thing. Okay, there's a do instead. So yeah. Not much to say about that really. So actually, I for C3, you don't need to do breaks. So something like this, right, would be you get it a bit more compact in C3, which I like. And most of all, in the case of this one, you would not have to do these, so it's like C3 would give you this instead. I can't do this in C, but that would be. Now you just have these, and that's why I actually don't. I think I suggest people use switches instead of if else statements in C3. All right, let me revert that. So. I mean, the code is not perfect here. It's just, but it's not horrible either. Not horrible. Oh, here we have. Oh, we have 3 nested ifs, right? So, what is this? Oh, it's this is code from translated from Clang. That's 3 levels. Okay. Yeah. Right. That's how we get 3 levels. Okay. Anything else, folks? Right. In C3 doesn't have pattern matching, but it has, as you know, this, right? People do should show people, like you get this in C3, so which you might know already, like you can switch. Oops, I don't like that code completion. So if test equals equals, I have to sum equals to 0. Then we can print test was 0. Case A is greater than B. Then I will print A is greater than B. And then we have default. Right. So you can do something like this. That's fine. Actually, let's write that one. So we have int test. It's going to return. If it returns 0, we have an A is 3 and B is 2, right? So running this. I forgot something somewhere. Default. So we get test is 0. Let's return this. And now we get the second one. Or we can also make that like this. And then we go to default. Right, so somewhat useful. I find it nice to use. Things get compact, especially if you want to. Sometimes you can just write them as this. I think this is a legitimate form of doing it. I don't know, like this. Maybe you want it like this, or maybe you want it indented. Either is fine with me. Both are readable. But you can do it like this, right? So now you can see what different things happens, and then blah blah blah. Right. Not quite pattern matching, but good enough for C, I think. Right. Anything else? Otherwise, I'll close shop for tonight. No? Well, I'm thanks you for asking questions. It's always fun to answer. I hope you saw I hope you liked the new enum feature. Did people like the new enum feature? Was it good? Now you've seen it in action, the enum lookup. Is that something you would think was good enough? What do you say, viewers? Maybe people, jumped in late. In that case, let's just show that. Oh, maybe it was something like this, right? We had this. Right, so you could do lookup like this, and now you can look up on that inline value. So 112 will look up Baz here using this lookup on the inline. So now we can go back and forth to the this associated value. All right, is that good? No one says anything. I guess I'll have to take that as a no or something. No, it doesn't look up as a hash map. As I said before, it's not a hash map. It's it just does a comparison. Right. So it will loop, or actually, it doesn't loop. It doesn't have a loop either. It is this function. Like you can rewrite the. It is this macro. and it will rewrite it. And this macro will basically rewrite it to these if statements. These are the ones that are left after this goes away. So if you want to look at how things work in like in a macro, you can like think about like all things that are prefixed with this $sign goes away. So that means that these are the things that are left. Now it happens to be that several of these lines, so actually it would be like 3 lines in that case, right? So we would have that particular type, so we will look at foo x, right? It would say foo x, and then like, sorry, not x, it's going to be like ABC, what is it, ABC, or what was it? It was hello, right? So it would be like hello x, you know, and then and the next ones and so on, and then would return the actual value there, which would be foo hello x again, right? So this is right. It's actually, it ends up being this in the end. So fairly small piece of code if you have few, and a lot of code if you have a lot of them. And if you want to optimize that, you can actually do that by rewriting this enum of lookup. All right. Okay. So you know, have a great weekend, and thank you for watching. Goodbye.